To make some application about what we have explained, so that you practice working with these voltages and current. Application 1 or exercise 1. Exercise 1 says a resistor of resistance R equal 150 ohm is carrying an alternating sinusoidal current whose expression as a function of time is I equal 0.12 sine 400 pi t, I in ampere, t in second. This means you have a resistor R of resistance 150 ohm, okay, carrying a current, alternating current. In alternating current, because alternating current change direction twice, this means when I put an arrow here, this means that this is the positive sense of the current I. No, for the resistor to carry current, a sinusoidal current I, it should be connected to a sinusoidal generator. Okay. You should know, in physics, you should know how to draw figures, how to draw a schematic diagram of an electric circuit. So practice this. Part 1 says, give the expression of the voltage UR across the resistor and deduce its effective value. So we need to find UR, then we deduce the effective value. What do you think about the solution? The one who knows will tell me to use Ohm's law directly, which is very simple. Ohm's law is equal R times I. So this implies UR is equal 150 times 0.12 sine 400 pi t. Using the calculator, 150 times 0.12 will give you 18 sine 400 pi t. Don't forget the unit. T in second, UR in volt. This is the expression of UR. Now we want to calculate the effective value of UR. What do you think? How to calculate the effective value of UR? You know the relation between the effective value and the maximum value is UR equal UR maximum over radical 2. So in order to find the effective value, you should find the maximum value of UR, which is 18. 18 gives you the maximum value of UR, or the amplitude of UR. So UR maximum is equal to 18 volt. Yani substitute, this implies UR is equal 18 over radical 2, which gives 12.73 volt. The second part says calculate the frequency of the voltage delivered by that generator. So the second part, he wants the frequency. Okay, the frequency, to calculate the frequency, you know that there is a relation between the frequency and the angular frequency. But how much is the angular frequency? As you know, this is in the form UR sine omega t. So the angular frequency is omega equal 400 pi radian per second. Using omega equal 2 pi f, يعني this implies f equal omega over 2 pi will give you 400 pi over 2 pi. Pi cancel with pi, you get 200 hertz. Okay. This was an application, or exercise 1, which deals about the resistor, how to calculate the voltage across the resistor, which is similar to that of the case 1. But here, as you see, we use the theoretical method. When do you use the theoretical method? You use the theoretical method when you don't have oscilloscope and when you don't have waveforms. You use the theoretical method. When you have waveforms, you use the experimental method. So here I use the theoretical method. Now the second exercise, which is exercise 2, and also it is application about this. Exercise 2, a capacitor of capacitance C equal 0.1 nanofarad is supplied with an alternating sinusoidal voltage U equal 0.1 cosine 3000 t, U in volt, t in second. This means that you have a capacitor. This is a capacitor C, and it is connected to AC generator. The voltage of the generator is U equal 0.1 cosine 3000 t. And بيقول determine the expression part 1, determine the expression of the instantaneous current. He wants the expression of the instantaneous current. Also, I should work theoretically because I don't have any waveform. So, how to find the current? As you know, this is the current I positive. As you know, the relation between I will UC can be found. Since this is a variable current, AC current, I can write I equal dQ over dt. And you know here that Q equal CUC. How much is UC? UC is not given directly. What's given directly is the voltage of the generator. But as you see, the terminals of the generator are the same as the terminals of the capacitor. So, you see here is equal to U. Only for this case, UC equal U, because terminals of C are connected to the terminals of the generator. So we can write now a Q I equal, I will make derivative for a Q. to apply this formula, I equal dq at dt, I am going to differentiate q with respect to t. Since c is constant, it will be outside the derivative, and so you get duc over dt. And since uc equal u, so I can write c du over dt. So I am going to substitute, but using SI system. In SI system, C should be in farad, I in ampere, U in volt. So I should change from nanofarad to farad. To do this, I multiply by 10 power minus 9 farad. 1 nanofarad equal 10 minus 9 farad. So you get 10 minus 10 farad. Substitute, بيطلع 10 minus 10 into derivative. As we said previously, this is constant multiplied. I put it aside. Derivative للcosine minus sine 3000 t times 3000. Okay, so what do you get here? بيطلع هون 10 minus 11 10 minus 11 3 times 10 minus 8 10 minus 8 times minus sine 3000 t. This is the expression of I. So I is equal minus 3 times 10 power minus 8 sine 3000 t, t in second, I in ampere. Okay? Let me suppose he asks you to find the phase difference phi of I relative to u. Here in this problem, which is the reference? If you look at u, you will find the phi of u equal to 0, and before the amplitude there is a plus positive with phi 0. This means that u is the reference. I is not reference because the minus here correspond to a phase difference. So in order to know which is the reference, there shouldn't be a minus sign here. So the reference here is u. Because of this, I am asking the question, find phi, phase difference of I relative to u. In order to find the phase difference of I relative to u, I should change the sine to cosine, because u is expressed in cosine. Also, I should remove the minus sign, يعني I should change minus sine 3000 t equal how much in cosine? In cosine 3000 in cosine. So using trigonometry, minus sine alpha بتساوي cosine alpha plus pi over 2. يعني this implies minus sine 3000 t is equal cosine 3000 t plus pi over 2. يعني so I is equal 3 times 10 power minus 8 cosine 3000 t plus pi over 2. I in ampere, t in second. Now the phase difference of I relative to u is pi over 2. You have here cosine, cosine, omega t plus phi. So here phi 0, here phi plus pi. Yani this implies I deduce that phi equal plus pi over 2. Yani this implies I leads UC by pi over 2. And this fits our experimental study and theoretical study of the capacitor. There in the explanation, our reference was I. And we get UC lags I by pi over 2. So, in the explanation, we say that UC lags I by pi over 2. I was the reference. Now, U, which is the same as UC, is the reference. So we will get I leads UC by pi over 2. Yani, if UC lags I by pi over 2, you will conclude directly that I leads UC by pi over 2. And this is what do we get. Okay? Now, he is saying to deduce the effective value, بدل effective value and its frequency. Similarly, effective value of the current. He wants the effective value of the current and the frequency of the current. Effective value, similar, using the formula I equal I maximum ala radical 2, you can get the effective value. And I maximum is this coefficient, which is before cosine, and it is positive. Why? Because as I increases, cosine increases. So I is maximum when cosine is 1. And you get I maximum 3 times 10 power minus 8 over radical 2. And you get and you get 2.12 times 10 power minus 8 ampere. The frequency from here, omega t, so omega is equal 3,000 radian per second, from which we can find the frequency as in the previous problem, omega over 2 pi, you get 3,000 over 2 pi, which gives you 477.71 hertz. Okay? The last exercise is about the coil. I explained the resistor, I explained the capacitor, and I explained the pure inductive coil. And here I gave an example about the resistor, an example about a capacitor, and now I am going to give a third exercise about pure inductive coil. In this exercise, he says a coil of inductance L and negligible resistance, which means that this is a pure inductive coil, is supplied by a current I equal 0.12 sine 400 pi t, t in second, I in ampere. I draw a figure the same as the previous ones, but here I am going to remove the resistor and place the pure inductive coil of inductance L. And behold, the maximum voltage of the coil is measured and found to be 10 volts. So you have UL maximum is equal 10 volt. And behold, part A says express UL of the coil in terms of L and T. فإذن he wants UL in terms of L and T. Also here, I don't have any waveform, I don't have oscilloscope, so I should work theoretically. Work theoretically means that I want a formula, and since this is a pure inductive coil, I will write L di over dt, which gives you L here 0.12 times 400 pi cosine 400 pi t. Okay, so you get 2 zeros, 48 pi L cosine 400 pi t, which gives 48 times 3.14 equal 150.72 L cosine 400 pi t. This is UL in terms of L and T. Okay? T in second, UL in volt. Now the second part is deduce the value of L, but the value of L type. How to find the value of L? From the previous explanation, we find that there is a relation between L will UL maximum, and as you see here, UL maximum is given to be 10 volt. From here, I can deduce how much is UL maximum. So, who can tell how much is UL maximum? In reality, UL maximum is 150.72 L. Why? Because this is in the form UL maximum cosine omega t. Or you can say, as UL increases, cosine increases. So UL is maximum when cosine is 1. And so you get UL maximum how much? But UL maximum is given to be 10. This means that L is equal UL maximum over 150.72, which gives 10 over 150.72, which is equal to 10 divided 150.72. يعطينا gives 0.066 Henry. This is the end of this session. Good luck, and I wish you to take care about these and study them well, and don't waste a lot of time